Hi there. My name is Elan Raja. I'm the CEO of Scan Computers. Scan is an NVIDIA elite partner for AI solutions. It's an absolute pleasure to be doing this recording for Advantech, who's a global leader in the fields of IoT, embedded systems, and industrial solutions. Now, there's such a great commonality between the visions of Advantech and Scan, whereby we both share a common interest of data processing, and AI in an industrial solution. Now, being part of the NVIDIA network and seeing how technology's evolved over the years, there's been a lot of documentation, a lot of noise within the market on AI, and it's seeing through what the noise is and seeing where the real life applications are. And as part of that, we often get asked to talk a lot about AI. And one of my opening parts of any discussion is talking about the fundamentals, which is data. And going back to some very early principles of physics, I kind of liken data to energy, almost like nuclear energy. The law of conservation of energy talks about the fact that energy cannot be created or destroyed. It simply changes from one form to another. And in the same way, data's evolving just like our need for energy. Data's gathered, transformed, transported, and consumed. It's the fuel source of what we do, and that's where it's like nuclear energy, in the fact that it's atomic. There's so much data that's growing at an infinite rate that actually extracting the information from that data is where the real energy comes from. So as part of that, there are two interacting cycles that we've seen across the years. And these two cycles are actually merging together. The first cycle is the business service life cycle, which really evolves around business functions, business operations, governed by legal and financial regulation, recently covered by data regulation, which is GDPR, all of which, with the growth of data and the growth of IT and security, led to the formation of data science. So these interacting variables are then capturing and merging with the data lifecycle, which is all about capturing data, processing data, analyzing data, taking action of all of those, then monitoring the action and reanalyzing. So the velocity of these two life cycles really depends upon which business sector you're in, what your use cases are, and that's where we're seeing the data life cycle in this form of data science interact with the business life cycle. And as part of that, the cycle helps in all areas, whether it be consultancy, security, legal, financial, industrial. And as part of that, we see data growing at an infinite rate. It's a universe within itself. Now, how do you extract the value of all of that data that's being gathered? The storing of that information is happening as I said earlier, at infinite places. And as a result of storage technologies that have advanced to store this vast volume, this universe of data, silicon's advancing at the same pace, at a faster pace even. Tech is allowing us to process data in parallel, in the volumes that it's being produced. So in many ways, going back to the sandal wearers within HPC from very, very early days for high performance computing, the rise of the internet, e-commerce, now IoT, it's a big bang for data. A lot of people refer to this as the kind of fourth industrial revolution. However, where we are at now in terms of its phases, that amongst this backdrop, there's mass change that's happening. Some of the most notable change is not just this explosion of data, but is in the processing of data in the form of high-speed networks, and more importantly and crucially, the actual processing unit. Now, very traditionally, it's been done on the CPU. A CPU has 26 cores and 56 threads. So if you imagine that as lanes of processing, then comes along a GPU, which instead of having 26 lanes or 56 lanes, it's got 6,912 lanes. Now, if you imagine this, where traffic can flow down to get processing, and you see such a vast increase of the number of lanes of processing, and then multiply that by multiple devices and then dense servers, we're into the era of parallelization. So if you combine the data lifecycle, the service lifecycle, advancements in data storage, and now advancements through the GPU in the parallelization of data. It allows for vast processing. On that vast processing, we can see reference that's been made over the years, and as part of it, what's happened is the market's changed through, and it's evolved with this parallelization of the growth of neural networks. So machine learning's been around for decades, but with these interactions, what's really going through is the processing of data through these complex neural networks that have come into fruition and into market are actually helping mass analysis of data for three general purposes. Classification, which is to predict something and determine whether it's one thing or another. Regression, which is to help look at huge amounts of data and almost predict a specific number. And then recommendations on chosen paths. Now, the part of this, the growth of neural networks and now the processing and the software ecosystem has really led to how businesses adopt this technology. So where does all this come together? How does AI actually work? Well, in many instances, it's down to the business. AI as a broad phrase used by itself is a cliche, but the business case is absolutely key. Having clean, curated data is one of the early steps of using machine learning / AI within a business environment. Seeing it as an R&D function within a business, building a MVP, a minimal viable product. Start with small data sets to see what the business problem is that you're trying to resolve. Have you got the data? What are you trying to solve? Is it classification, regression? And then start using small extracts of data to start building up this minimum viable product, and then start to scale that across the organization on large data sets. So we refer to these stages in which this process happens within a business as the development stage, which is where you take small samples of data and start playing with various algorithms and processes, whereby we're taking data and modifying data to a point where you develop. Once your model's developed, you then take that developed model and transfer it into the stage of training, which is to use the development model, but on huge amounts of data. That takes time. And once that's done, you then take the information, condense it all, and just have an algorithm at the end, which is used to infer the huge amounts of processing that took time to do, and then make the relevant decision. And the end result is that you get a trained algorithm that's able to make decisions faster, more efficiently. So in a very simplistic way, I kind of see training like swatting for an exam, cramming all the information in, and I see inferencing as sitting the exam on exam day. Now, with that in mind, we can see that to get the level of parallelization and processing involved in a traditional data center to what it is now, NVIDIA and Advantech have used GPU technology to reduce the footprint within data centers. The performing capacity is so great that it's exponential, and it's growing in line with this infinite data. So if we take these three stages that we've discussed, develop, train, and inference, what we've done is built an ecosystem around these three phases. With Advantech, we've helped curate and develop hardware that's used for training. We have optimized storage solutions. GPUs are so fast that unless the storage subsystems are fast enough to keep the processing and can ETL, extract, transfer, and load data within the GPU ecosystem fast enough, the GPUs will throttle. So it's all about having super fast storage that can keep the GPUs fed with data. In order to do that, it needs fast networks. Companies like Mellanox will produce all of the networking equipment that allows storage to connect to a wider network. There are endless software solutions, whether the solutions are managed via on-premise or cloud. All of these variables are brought together with professional services. And it's the combination of these variables that actually allow solutions to be deployed and delivered. So on this workflow of development, train, and inference, focusing clearly on the industrial use, within data centers, this is where you have massive amount of data and storage. So this is where systems like the NVIDIA A100, which is a groundbreaking technology, groundbreaking GPUs in a groundbreaking ecosystem, interacts with huge amounts of data. That this is where the heavy lifting, the workload is done. But there's often masses of lag between transferring data from on-premise to the data center, doing the whole kind of, the process of what I mentioned before in terms of building the MVP and then starting to run these models. That in order to reduce that lag, on-premise industrial training systems were created, which were industrial ready. Industrial servers designed to work reliably and consistently in high temperature and harsh environments. This wasn't always possible for a lot of the kind of core performance, which is done in the data center. But when it comes to be on-premise and industrial environment, this is where Advantech have designed some very, very specific systems, all rated to work in these harsh environments. So you almost get an effect of retraining on-premise, but mass training within the data center, and the two combined. But whichever approach of training that is taken, the industrial environment then leads to edge devices, industrial edge devices. And this is where the algorithm from these trained systems is deployed on low power units casted so far out within the edge of the company's network that it allows for decision making, regression, prediction, all the things that we talked about earlier to take place. So these use some very fundamental technologies which have been designed by NVIDIA. Jetson, which is a 5-watt computer, moving all the way up to Xavier, which again is an addition of the Jetson platform, and it's used in many applications from robots to drones to autonomous machines. But the fundamentals behind all of this is the understanding of develop, train, and inference. Now, with that, it leads to a model where you have on-premise and off-premise training. That gets moved through, depending on the business, to a cloud environment. And then from the cloud environment, you can actually manage through a whole host of different software suites, the edge and inferencing, be it network video recorders, edge devices in water meters, applications from drones to, I can go on and on about the applications, and I'll come on to some of the applications in a moment. But the inferencing devices are so many that this is where IoT and AI absolutely start to blend together. If you think of how many data points there are coming out of all these IoT devices, to gather that data, to process that data, to make sense of that data, whether it be classification, regression, recommendations, whatever that happens through, it's the edge devices that are making this in some very harsh industrial environments. As part of that, how do you apply these to business cases? Well, let's look at it from a design perspective, whether it be model simulation, designing manufacturing and serviceability, whether it be in supply chain, forecasting, supply chain optimization, manufacturing in the point of robots, predictive maintenance, process control systems, and even services for predictive maintenance, field inspection, logistic optimization. The uses are so many, and it comes back down to taking those initial steps of building the MVP and combining this ecosystem of software drivers together to start building solutions. But the good thing is that the solutions, the skill sets are all available, along with this boom of parallelization and GPU technology. So we've worked very, very closely with our core partners, NVIDIA, Advantech, in delivering solutions. And I'm going to splash up a slide on screen to see the broad range of uses that we've applied this same ecosystem and model to across different industries, everything from medical, industrial, defense, petrochem, car manufacturing. It's about businesses adopting the early model of what I said very early on within the presentation of how to use data and likening data to a new form of energy that's found by extracting data from the huge swaths of what's been created within an organization. I hope you found that useful. SCAN, along with Advantech, have built a POC environment which we encourage our customers to come on board and trial, where we can help and build these MVP solutions with you and give you access to a lot of the technology that I've just talked about over the last few minutes. So with that, feel free to get in contact. We look forward to hearing from you. And on that basis, good luck in all your AI projects. Absolute pleasure. Thank you.